Welcome back, class, to EPSY 255. And in this lecture, we are going to start talking about the second substage of the pre-operational stage. And that is intuitive thought. The substage is intuitive thought. When you think of the word intuitive, what's going to give you a clue about what this stage is about is the word intuitive. And the word intuitive, it means that you are very curious. You're asking a lot of questions. And this substage occurs between 4 and 7 years old. And that is when children constantly question everything. Why? Why is this like this? Why is the sun in the sky? Why are the stars in the sky? Why are trees green? Why do trees die during the winter? These are samples of questions that kids between the ages of 4 and 7 years old are going to ask. They're very inquisitive. They're trying to get an understanding of what they know and what they don't know. An issue with pre-operational thought, the pre-operational stage of cognitive development, is something called centration. Centration is one of the limitations of the pre-operational stage. When you think about centration, think about the word sense, the center. And so when children are in this pre-operational stage, they tend to focus only on one characteristic of an object or a person, and they exclude all of the other characteristics. So they really focus in on one characteristics and forget about all the other characteristics that make up this object or this person. And centration is an example of children having a lack of conservation. They have a lack of conservation. And so conservation is the understanding that when objects or substances appearance change, that doesn't mean that the object or the substance basic properties change. And we're going to watch a video next to really help us understand centration and conservation.
So I'm going to make 2 rows of quarters. Okay. Does this row have more quarters? Does this row have more quarters, or are they the same?
The same.
The same? Okay, now watch. Now, does this row have more quarters? Does this row have more quarters, or are they the same?
That one has more quarters.
That one has more quarters?
Yeah.
Why does that one have more quarters?
Because it's stretched out.
Because it's stretched out?
Yeah.
Okay, so how many are in this row?
1, 2, 3, 4, 5.
Okay, how many are in this row?
1, 2, 3, 4, 5.
So, are there more in this row, or are they the same?
The same.
The same?
Yeah.
Okay. Okay, so we got.
Okay, so that was a good example of centration. And the focus here for the child was the length or the how wide apart the quarters were. Even though there were the same amount of quarters in each row, the child first said that the row where the quarters were spaced out, there were more quarters in that row. So that's centration. He's focusing on how wide, how long the row is, and excluding that the quarters are the same. They're the same amount of quarters at the one row as they are at another row. Let's continue.
2 sticks. Is this stick longer? Is this stick longer, or are they the same?
The same.
The same? What about now? Is this stick longer? Is this stick longer, or are they the same?
That stick is longer.
The stick is longer?
Yeah.
Can you tell me why?
Because you moved it over.
So now it's longer.
Yeah.
Okay, tell me. I'm going to pour blue water.
Same thing. The child was able to understand that when the strings were in the rows together that were made them the same length, that they were the same, but the child wasn't able to understand that if you move the string, the stick or the string is still the same length as the other. So that's a lack of conservation, and that is an example of centration. Let's look at another one.
Each of these cups, and you're gonna have to tell me when they have the same amount, okay? Okay, tell me when this one is the same.
The same.
The same? Those two are the same now?
Yeah.
Okay.
Look at him measuring it out. So cute.
Good.
The white is the same.
Good. Okay, now watch this. We're gonna take the blue water from this glass, and we're gonna pour it into this glass. Now, does this glass have more water? Does this glass have more water, or are they the same?
Had more water.
This one has more water? Can you tell me why?
Because that one's higher than that.
That one's higher than that one, right? Can you tell me?
And for this last example, the child originally said that the two cups had the same amount of water, but the child wasn't able to understand that the same amount of water has been poured into the other cup. The child believed that there was more water in the taller cup, or more liquid in the taller cup compared to the smaller cup because of the size. So again, that's a centration. They're focusing on the height of the liquid. They have a lack of conservation. They don't understand that the liquid is the same, even though it is in another. The amount of liquid is the same, even though it is in a different container. All right, so let us go to another slideshow, and gonna go to part 2. All right. So we talked about the sensory motor stage. We talked about the pre-operational stage. Now what we're going to do is talk about the concrete operational stage. And as you can see, that occurs approximately between the ages of 7 to 11 years of age. So let's hop into it. Concrete operational stage. This stage, children are no longer basing reasoning on how they feel. Now children are basing their reasoning on concrete examples and evidence, or in other words, logical reasoning. Children are also able to do concrete operations, which are reversible mental actions on real objects. So, for example, when we talked about in the last video how the child was unable to understand that the amount of liquid is the same, even if it's placed in a bigger cup. But now, if you ask a child that during this concrete operational stage, they're able to mentally be able to reverse what the interviewer had done, which was put the liquid into a bigger cup. They're able to reverse that and reverse that in their mind and understand that it's the same amount of liquid. They're also able to classify objects during this time. And as I stated, they have mastered conservation. And as I was hinting at earlier, the conservation tasks that you ask a child to do allow the child to perform concrete operations. As I stated previously, the concrete operational stage is classified during this time, children are able to classify, really be able to classify different things, and such as relationships. So, for example, when we talk about person J that is in this picture, a child is able to understand that person J is the child of person D, and the children are able to understand that the person J is also the mom or the dad to persons K, L, and M. So they understand mothers and daughters relationships, children and grandparents and parents relationship. They're able to classify and they're able to understand those relationships. Next up is the formal operational stage. This occurs between the ages of 11 and 15 years of age. And during this time, individuals are really get a better understanding of hypothetical deductive reasoning. So individuals are able to move beyond concrete examples. They're able to think in abstract but still more logical ways. So they may be able to develop hypotheses, which, is going to be important as they grow up. They're going to be able to deduce and come up with solutions, and they're going to be able to decide what is the best path. They're going to be able to do this even without going down different paths because they're able to understand and picture what may happen in their minds. So that's a hypothetical deductive reasoning. That is a trademark of the formal operational stage. Piaget really is influential in education. And so what Piaget did with this cognitive development and these stages of cognitive development, he really helped us to have a conceptual framework for understanding education and how we educate children. And so I'll talk about a couple of the ways that he changed the education system through his theories of cognitive development. So, for example, he says that we should facilitate rather than direct learning. So what that means is that when you are teachers or you're social workers, psychologists working with children, it's important for you to make situations in the classroom or in the office for students or for children to learn rather than do direct working, which is like, examples of math problems, coming to the board, doing math problems. Make situations in the classrooms that the child has to manipulate, and then that helps to build their cognitive development. And number 4, that's one of the other ones that we're going to talk about, promote the student's intellectual health. When we talk about the intellectual health, we are trying to focus on children not being pressured or pushed into achieving too early in their environment. What we should be doing is really seeing where children are now, which is what you are currently doing as you are getting a better understanding of Piaget's theory of cognitive development. You're seeing where the child is cognitively, and then you can allow for the child to learn at their pace. Lastly, I want to talk about Piaget's contributions and criticisms. One thing that I do want to talk about for the contributions was that Piaget was a GOAT. Okay, he was one of the greatest of all times in observing children. And he really understood what observing children meant and was able to have this theory based on what he observed. But a criticism of Piaget is that his averaging of times where cognitive abilities emerge. Sometimes the cognitive abilities can come earlier than he expected, or sometimes those cognitive abilities can come later, but the child can still be involved in neurotypical development. Also, he really downplayed culture and education. Culture and education, they really do have a strong influence, a stronger influence than what Piaget said. Okay, I'll see you all in the next video.